All right, so we are working more on equation solving today. We're going to do some funky stuff with U substitutions and some more factoring and trig trades, okay? This announcement, guys, is posted around the room, but the next thing expiring will be everything up to, but not including law of sines and cosines, okay? So if any of the graphing or modeling you need to retake or take for the first time, it has to be done by next Tuesday. Yep, I don't know why I shut that. Okay. All right, so at the top of worksheet 4, anybody start us out how we would do this number 1 right here? Good job. Take out a cosine. Then it would say the sine of x minus 3 equals 0. So we have either this one or this one could equal 0. If the cosine of x is 0 or the sine of x is 3. Can the sine of x be 3, guys? Whoop, that was a horrible graph, but it goes up to 1 and down to -1, right? So this does not ever happen. All right, so then we're just looking for where the cosine is 0. The cosine is x, so I'm thinking that it's 0 up here at 0, 1, and down here at 0, -1. So the value of x that would make that true would be pi over 2 and 3 pi over 2. How am I doing? Anybody lost? Okay, is that it? Anybody remember this business? When it says all values, what do we have to do? Yeah, we have to say plus every multiple of 2 pi after that. And you can just put plus. I always put plus or minus, whatever. Any questions? And there are shorter ways you could write that, but I'm not going to spend a lot of time on that unless someone has a question about one. You could have just said pi over 2 plus or minus pi n because they're straight across from each other. Or plus or minus pi over 2 since it's 90 degrees up and 90 degrees down, okay? All right. This is the kind of question that is on the quiz. Anybody remember what we did on Friday, Thursday, Tuesday, Wednesday last time we had class? Okay. When it said sine x, we could not trade because everything, the only trades we have are for squared quantities. So we have to leave sine x right there. But what could we trade a cosine squared for, guys? 1 minus sine squared, right? Because sine squared plus cosine squared equals 1. So cosine squared by itself, we would have to subtract that over there, do a 1 minus sine squared. Okay, so we traded that out. Then we still have this all back here, plus sine x plus 1 equals 0. All right. What do you want to do now? Well, I can for sure combine those like terms, right? That 1 and that 1 makes a 2. I'm not a big fan of this. Anybody remember Hofbauer's rule about factoring? Yeah, I don't like a negative out here, so can I just multiply everything by -1 so that it becomes sine squared minus sine x minus 2 equals 0? Now how will that factor? And it does not take a sign out. And heaven forbid I cannot move the 2 over to the other side and then take a sign out. The only time I can factor something out, what has to be true first? It must equal 0. Thank you. Destiny, it's for you. All right, so any ideas? If I pretend this is a variable, I have something squared minus something minus 2. How would that factor? something with a 2 and something with a 1, a -2 and a +1, would that work? So my something is going to be what? Sine times sine. One needs a 2 and one needs a 1. I need the -2 in the middle, and this would be a +1. Everybody okay? That's how that would factor. So then I have the sine of x equals 2 when I set this equal to 0, or the sine of x equals -1 when I set this one equal to 0. Can the sine ever be 2?
No.
Can the sine be -1? Okay, where am I looking for that? It is a y value, right? Because it's sine. So the only place the y value is -1 is down here at 3 pi over 2. And it would repeat every 2 pi because it does still say all values. All right, I think I may have put this one in my calculator so that we could. Is this one in there, guys? Cosine squared plus sine x plus 1. Okay, if I set my window, again, I'm in radians, set my window 0 to 2 pi, and I graph, do you see that there's only one place that it hits 0? And then it would repeat every 2 pi. Now that's a funky looking graph, right? Why is it all positive? Because this was a squared quantity, that's going to be positive, right? And the sine graph was shifted up 1, or that component of it. They're added together, but okay. So I think we're good there. What could we trade a tangent squared for? This is very similar to the one we just did. We can't get rid of secant, but what can we change tangent squared for, guys? I'm not good with this one. I hope it's something with secant squared minus 1. So if I combine like terms, I have a secant squared plus a secant minus 2 equals 0. That will factor similar to the last one, but not the same. And it's a secant, so we got to be careful. Secant of x, one needs a 2 and one needs a 1. I think I need a plus 2 this time though, right? To get a plus 1 in the middle. Again, remember, you can always do n squared plus n minus 2 and factor that. And check that you have your factoring all right. And then once you're happy with it, put in the word secant. All right, if I set those equal, I get the secant of x equals -2, or the secant of x equals 1. Now, if we're looking for exact values, does anybody, this is on the quiz, there's a reciprocal function. What happens when you have the secant of x equals -2? This is 1 over cosine. So what can I do to both sides? So I would have the cosine of x equals -1/2. And what about this one? The cosine of x equals the reciprocal of 1 is just 1, right? All right, so now I'm going to do a little sketching here. The cosine of x is an x value. I'm thinking -1/2 in the x spot would happen there and there, which would be 2 pi over 3 and 4 pi over 3, seems right to me. And then the cosine value and x value of 1 would only happen here at 0. All right, did it say all solutions? Only between 0 and 2 pi. So I'm thinking I should just have these three values, okay? Now, I do have a graph here of this one. It's not a good window though. I don't know why I put that on here. But doesn't it appear that if this is 0, 1, 2, and then again at 2 pi, so there's 1, 2, 3 solutions before 2 pi? Everybody thinking we're okay? That supports our answer here. All right. You may want to just watch this one because I'm not going to put this on the quiz anyway. But this is the kind where there's nothing to trade. So we actually would have to square both sides. Yeah. So when you square 1 plus cosine times 1 plus cosine, someone tell me what we're going to get. Does everyone know where I got 2 cosine of x? And then a plus cosine squared. Now if I square this right-hand side, it's all multiplied, so I don't have to distribute, but what's square root of 3 squared? And sine, then I square that, it will become a... Now, which one do I need to get rid of? Remember, I can't get rid of anything that's not squared, so if I have to keep the cosine, then I want to get rid of sine squared, okay? What can I trade out a sine squared for? All right, so distribute that 3 for me, and I have a 1 plus 2 cosine of x plus a cosine squared equals 3 minus 3 cosine squared. Okay, if I add them all over here, how many cosine squareds will I have? 4 cosine squareds. There's a plus 2 cosine of x. And then if I subtract that 3, I'll have a minus 2. What can I do to all that mess? Take out a 2. Now does it feel like the same one we factored 3 times today? Kind of? I don't know, the 2 is maybe not, I don't know. This is a 2 cosine. Maybe the 2 was at the back with the other ones we did today. The only way to get a 1 back here is a 1 and a 1, right? Now there's a 2 out front. Can that 2 ever equal 0? No. Let's see. We need 1 to be plus and 1 to be minus. I think this one plus, so that we have a positive 2 and a negative 1 to get this in the middle. So then set this equal to 0 for me, and what will I have? Cosine of x will equal 2 cosine of x minus 1 equals 0. Add the 1, divide by 2, I get 1/2. Everybody okay? And this one would be the cosine of x is negative 1. All right, if I picture where the cosine is 1/2, I think I get pi over 3 and 5 pi over 3. Somebody checking me? Cosine positive 1/2 at those two places. Is that true? And the cosine is negative 1. The x value is negative 1 over here at pi. All right, was this 3 solutions only? Yes, only between 0 and 2 pi. I think this one might have an extraneous solution. So I think I graphed it. I'll turn that one off. Is this what it had originally, guys? This one, 1 plus cosine of x equals the square root of 3 sine x? So if I turn both of those on, I want to see where they intersect. And it looks to me that I only have 2 solutions, okay? What did we have? What was the first one? Pi seems to be working to me. If we go to pi, I think we're good. The first one here, we had a pi over 3. If we go to pi over 3, that does appear to be the other one that works. Let's look at why 2 pi over 3, or 5 pi over 3, I'm sorry, is an extraneous solution. So we got pi over 3 and pi were the two that worked. 5 pi over 3, if we put it in the original function here, what is the cosine at 5 pi over 3? It's 1/2, right? So we'd have 1 plus 1/2 equals square root of 3 times, what is the sine at 5 pi over 3 though? It's negative square root of 3 over 2. So when I multiplied this together, I would get negative 3 over 2. Is that ever going to equal 1 plus 1/2? Okay, because of the sign difference, that's why it didn't check. So we wound up with only 2. But again, not going to give you one where you have to square both sides, and not going to give you one like that with an extraneous solution. So grab your graphing calculator, because I have no idea where this is true. Generally, what we do when we are solving by graphing is we solve for all solutions, or on the graphing calculator, we can solve just between 0 and 2 pi. Now, before I had a graphing calculator, what I had to do on this kind of a question was I had to picture the sine graph. This particular one says, where is the sine negative 0.729? So it was down here. And something interesting happens when you go to the home screen of your calculator and you type second sine of negative 0.729. I'm going to get a negative answer. I am in radians. I'm doing inverse sine, so I'm looking for an angle in radians, and it's giving me something in the 4th quadrant. Does anyone know why? When we do inverse sine, remember the range said we could look in this quadrant or this quadrant only? And the calculator found a negative here. It found this one. Now, I would have had to know the symmetry. I would have had to know that that means if I go the same distance, this little green segment in here, if I go that far past pi or in front of 2 pi, I would find the 2 solutions I need. All right, you guys are in luck. You don't have to do any of that. What you have to do is go to your calculator, set your calculator in radians, type in sine of x, not inverse sine, just sine, and then that constant, was it negative 0.729, guys? Okay, then go to your window and make sure your window is set for 0 to 2 pi here for your max and min of x, and you can literally type 2 pi. Then when you graph, you want these 2 solutions, and that's it. So you're going to find the intersection point. Enter, enter, enter. One of them is 3.958. And the other one, second trace, intersect, enter, enter, and I want to scroll over so that I'm closer to this one. And hit guess or enter. And 5.466. So the 2 values I got between 0 and 2 pi were 3.958 and 5.466. It says in radians to the nearest, oh, it does say one more place. Is that what it says up there? Okay. This would be a 5, and this would be a 3. I don't know, that's a lot of decimal places. Okay. Now, how do I change that to all solutions?
Plus or minus.
Yeah, it's going to repeat every 2 pi. So I can say 3.9585 plus or minus 2 pi n and 5.4663 plus or minus 2 pi n. Now, it does get more complicated because not everything repeats every 2 pi. I did not put one, I used to always quiz on one like this, but I didn't put one on, but I just want to show you this, so you don't really need, this one I could give you because it's just between 0 and 2 pi. So I just want to show you how goofy the graph can get. So I have it in 6 and 7, does that look right, guys? This, and then it's supposed to equal 3. Is that the right question? Okay. Look it, isn't that fun? Okay. So if it was just between 0 and 2 pi though, how many solutions would I need to find? 4. And what do I write down for my answers? When I find one of those solutions, what do I write down? Only the x value, yes. Okay, I had to get closer to the answer. It didn't find the answer in that. But I write down only the x values, okay? Because this one said equals 3, I do the intersections. Okay, let me try that one more time. And I only want the x values at those points. And there was, what did we say, 4 of them? Okay, I'm not gonna worry about it. This one says the tangent is 6. Again, it says all solutions. How often does the tangent repeat? Every pi. So we can put plus or minus pi n. I don't even need to graph this to find a solution. Anybody know where I could find one solution real quick? Couldn't I go second tangent, what was it, 6? On the home screen? And it gives me 1.4056. And then it would repeat every pi. That's all I really need because a tangent is going to repeat every pi. If you graph it, it's going to show you 2 solutions because from 0 to 2 pi that would hit twice. All right, this is the new stuff. So wake up. Really important, okay? Stretch, turn your brain on. When you have a function with a number inside of here, we are going to do what we call U substitution. We're going to call this just U for a minute and solve, okay? I'm going to actually start with number 10. So if I substitute a U there, it will say this. And I'm going to solve. I'm just going to look at my unit circle. The y value is supposed to be a negative square root of 3 over 2. So I'm thinking, oops, not x, but y. Sorry, I didn't leave. I'm thinking that happens at 5 pi over 3 and 7 pi over 3. Is that right? No. Okay. 4 pi over 3 and 5 pi over 3. All right, sorry, my brain was not clicking there for a minute. Okay, and I didn't write that correctly yet because, what does it say? Oh, I'm struggling. It says all solutions, right? So we put a plus or minus 2 pi n on the back. And we're not done. So it's really what we've been doing, but we're adding another step. The extra step was, this is not really a U, it's a what? So I currently have 2x equals all of this, or 2x equals all of this. What do I have to do to get x all by itself still then? Divide everything by 2. Now, be real careful. Dividing by 2 is really taking half, right? So if I take half of all that, half of 2x equals 4 pi over 3 plus or minus 2 pi n. If I take half of all that, what will I get? X equals 4 pi over 6, which would reduce to 2 pi over 3 plus or minus, instead of 2 pi n, half of that would be pi n. Okay? And if I take half of this other one right here, half of 2x would be x. 5 pi over 3 divided or multiplied by a half would be 5 pi over 6. And half of 2 pi n would be pi n. Now let me explain to you why this is true. What does the sine of 2x look like? When I told you way back when to graph the sine of 2x, what was it? Yes. How did you change sine of x to sine of 2x? What did the 2 inside of here change? It changed the period to 2 pi over 2, which was pi. So the graph looked like this by pi, okay? So does it make sense that it's going to repeat every pi, not every 2 pi, because the period has changed? All right, and it was scrunched in, so instead of 4 pi over 3, it hit halfway there at 2 pi over 3, and instead of 5 pi over 3 being the other place, oh, it was negative, not positive, sorry. It's hitting down here, because we were graphing where it hits negative square root of 3 over 2. So it hit at 4 pi over 3 and 5 pi over 3, but we scrunched it up, so now it's at 2 pi over 3 and 5 pi over 6. All right, back to this question. What if I want only the answers between 0 and 2 pi, guys? I shouldn't have erased that graph, because how many periods does it have between 0 and 2 pi now? So here was 2 pi over 3, and the next time was 5 pi over 6. Actually, this one was 5 pi over 6, and this was 2 pi over 3. But where's the next time it's going to hit? We have to add an entire cycle onto that again, which would be plus pi. So add 3/3 to that, and what do you get? Oh, 5 pi. And add an entire pi onto this, which would be 6/6, so we'd have 11 pi over 6. So if I said find the sine of 2x between 0 and 2 pi only, there would be 4 solutions because the period had changed. Now, I don't know what Abruzzo told her students, but I'm going to tell you right now, this question on the quiz is all solutions. So you don't have to actually do that, you have to do this. Okay, I think this is easier over here when you just find it in the unit circle and then divide everything by half or whatever it is. So let's try another one. Actually, I'm not going to do these two. These are just graph on your calculator and find your answers between 0 and 2 pi. Can everybody do that? And answer as decimals. Everybody good? Okay. All right, go to the back of the worksheet. I'm going to do number 1 with you. The assigned problems are actually not the circled ones on this side. All right, so we're going to practice the 0 to 2 pi thing. All right, how do we isolate the function here? What can I divide out of here? The negative 8. Yeah, I can't divide the 2 out inside, but if I divide both sides by negative 8, it now says the cosine of 2 theta is equal to what? 4 over negative 8 would reduce to, yeah, so everybody good that that's where we're at? Okay, now, this is going to be a u substitution problem, so I'm going to say the cosine of u is negative square root of 2 over 2. Stay with me here, guys. On the unit circle, where is the cosine? The x value, oh, I can't draw. Negative square root of 2 over 2, and down here, there's another one at negative square root of 2 over 2. Is it 3 pi over 4 and 5 pi over 4? Okay. And those would repeat every 2 pi. But that's u. What is u really equal to in this problem? 2 theta. So I have 2 theta equals, so how am I going to solve for theta? Yes, I'm going to take half of everything here and half of everything here. So when I take half of the first one, I get theta equals half of 3 pi over 4, guys. Multiply the top and I get 3 pi, multiply on the bottom and I get 8. Plus or minus, what's half of 2 pi n? Okay, this is on the quiz. Some of you are like totally spacing out here. Okay, we ignored this 2 and found the solutions where the cosine is square root of 2 over 2. There was 2 of them, and we put plus or minus 2 pi n. Then to get rid of that 2 inside of there, we now have to take half of everything. And that's where we're getting goofy answers that we are not on our unit circle. All right, we need to do it with this one as well. Half of theta, 2 theta is 1 theta. Half of 5/4 would be 5 pi over 8. Half of 2 pi n would be pi n. Now, if that was a quiz question and it said all solutions, you'd be done. This one doesn't say all solutions. It says from 0 to 2 pi. So one of my answers is 3 pi over 8, and one of my answers is 5 pi over 8. But I can add pi and still be less than 2 pi. So what is a pi added onto that? If I add 8 pi over 8, I'd have, and that's less than 2 pi, right? 11/8 is 1 3/8 or something. It's less than 2. All right, now if I add 8/8 onto this one, I get, okay, now if I added another 8/8 onto either one of those, it would be more than 2. Does everybody see that? Okay, so this is the painful way to get from 0 to 2 pi. But if I had left it all solutions, could we have gotten to there at least? Okay. Let's try another one. Let's try number 3. Oh, this is a tangent question. And it looks real ugly to start with. I think the first thing I'm actually going to do, over here, guys, 3 over 3 plus the square root of 3 over 3 is the same as that. Do you see what I did? Because now what can I do? To get this to say tangent all by itself over here, I need to subtract 1. And isn't 3 over 3 1? So that goes away. All right, I would ask the question like that. I would start the question right here. Now, what are you going to have to do if this is a tangent question? There is not anywhere on my unit circle where I can find square root of 3 over 3 for tangent. What kind of an ordered pair am I looking for? 1 and square root of 3? Does that work? Because when I put y over x, I get square root of 3 over 3?
Yeah.
All right, so I'm looking for that ordered pair, which happens in quadrant 1. Okay. It happens here, right, at pi over 6? Am I right? Okay. Then where's the other place on my unit circle that I would get a tangent of square root of 3 over 3? Straight across from that, because tangent repeats every pi. So if I had a negative square root of 3 over 2 and a negative 1/2, which would be what? 7 pi over 6? Is that right? Is 7 pi over 6 have the same ordered pair, but they're both negative? Okay? Now, how often do those repeat? Every pi. All right. And what do I still have to do? Yep, I have to get rid of the 2 by multiplying through by 1/2. So if I take half of all this, what do I get? Pi over 12 plus or minus pi over 2. And if I take half of all this, 7 pi over 12 plus or minus a pi over 2. All right, it asked for what, 0 to 2 pi? Ugh. Okay, so a pi over 12 is 1. A 7 pi over 12 is 1. What if I add a pi over 2? Anybody get a common denominator? Actually, you can use your calculator. Do 1/12 plus 1/2. Math, enter, enter. What do you get? Should be 7/12, which is the one we already have, right? What if you add another 1/2? So 1/12 plus 1, math, enter, enter, is a what? Oh my goodness. So 13/12, is that less than 2 pi? 13/12 is not less than 2?
Yes.
Okay. What if we add another 1/2 to this guy? So 7/12 plus 1. I got 19/12. Is that less than 2? Okay. I do hereby solemnly swear it won't be a tangent question and it won't be 0 to 2 pi, okay? So let's try one that's not. What's another one? That's this one? I like this one. It might be one with a 3 on the quiz. Okay, not a 2 in there. But it also, I like this one because it says all solutions. All right, so on the left side, it has a negative 2 over 2 plus square root of 3 over 2 equals negative 1 plus sine of 3 theta. That's a 3. Okay, if I add 1 to both sides, what's left? Just a square root of 3 over 2 is equal to sine of 3 theta. Okay, be awake, because this is a question that could be on the quiz. Everybody ready? So what you do is you look for where is the sine square root of 3 over 2. The sine value is square root of 3 over 2. I'm thinking, how did I do? Is it pi over 3 and 2 pi over 3? And it's plus or minus every 2 pi n. But that's 3 theta. So what do I still have to do? 3 theta equals, and 3 theta equals. So I need to divide by 3 or take 1/3 of everything. Okay, if I take 1/3 of all that and 1/3 of all this, My final answer, and it is my final answer, is going to be theta equals, what's third of pi over 3? Pi over 9. A third of 2 pi n would be 2 pi n over 3, right? Everybody good? A third of 2 pi, okay? And then this one, a third of 2 pi over 3 would be 2 pi over 9 plus or minus a third of this would be 2 pi over 3n. No, doesn't matter. I did both just to be, it should not be on the bottom, which mine kind of looks like on this one. Good question. All right. Is there one more that's circled? No? Okay, so this is your assignment tonight, guys. There's just 4 things on the book work, and then the 4 problems on 4B.
Was that the worksheet we were just on?
Yes, worksheet 4B we were just on. The ones you have to go back and do are 2, 4, 6, and 7.
No fact.
Okay.